Okay, here we go. I taught you last week Thursday. I know it was a long time ago. We've had some snow days here. But I taught you what y is equal to 3 cosine of 2x looks like. You remember that? Let's try to refresh our memory. Do you remember what the amplitude was? Positive 3. It's always the absolute value of a. Do you remember what the period was? So 2 pi over 2, which was pi. That was the period. Very good. Yep. And that's what we did. And we sketched the graph. Okay, it was a negative 3. We know cosine starts at the max or the min. Since negative 3 started at the min, we graphed it. Well, today we want to extend that a little bit further. Instead of talking about the amplitude of the period, we want to do this. Y is equal to negative 3 times the cosine of 2x minus pi over 2 plus 4. And we want to be able to graph the horizontal and vertical shifts as well. And you're totally going to be able to do it. Are you ready? Awesome. Let's go. We have 1 page of notes, and then you can work on your assignment. Office Friday on Friday. Yep. You want Office Friday today because you missed last Friday. Okay. At this rate, we won't be able to do anything. So, amplitude is the absolute value of A. The period is 2 pi divided by b. Those do not change. But if you have a function of the form y is equal to a sine of bx minus c plus d, or y is equal to a cosine of bx minus c plus d, the vertical shift is just d. It's that number on the end. That's pretty easy, right? And then if you want the horizontal shift, you take bx minus c, and you set it equal to 0. And you solve for x. Whatever you get, that tells you the horizontal shift. Piece of cake, upside down. Now, what order do we examine these things in? I will tell you that you should apply the transformations in the following order when graphing. Number 1, start with the vertical shift. I'll look at the graph right here. We're going to start with the example B, and then we'll move back to A. But can anybody tell me what the vertical shift is? It is 2. Very good. So you move the x-axis d units, and that's going to be the axis of rotation. So I'm going to move it 2 units. That's on the inside, but here, when it's on the outside, it's exactly what you think. Excellent question. Thank you for asking that. Then we look at our amplitude. What is the amplitude here? So I have the vertical shift is 2, and I have the amplitude is 3. So this is the first real critical thinking piece you have to consider. If my vertical shift is 2 and the amplitude is 3, what do you think the maximum value is of the graph? It is 5. That's the maximum value. So use the amplitude to determine the maximum and the minimum. Can anybody tell me what the minimum value is going to be? -5 is the most common response. Unfortunately, it's not correct. -3 is also a very common response. Unfortunately, that is incorrect. -1. Noah, can you tell us how you came up with -1? So from the vertical shift, you moved up 3 and down 3. So you took the 2 and you added 3 and you subtracted 3. We good? So that's my horizontal axis of rotation. That's where I'm going to move up and down from. Yep, I would draw that. Period. What is it? 2 pi. Excellent question. I take 2 pi and divide it by the b value. The b value is whatever is in front of x. There's a 1 in front of x, so it's just 2 pi. I divide it into how many parts? Why? because there's 4 quadrants. It takes sine and cosine 4 quadrants to repeat itself. And finally, we go to our horizontal shift. There's nothing inside parentheses here, so there is no horizontal shift. Horizontal shift is the most complicated part, and we'll look at that in our next example. So it's a cosine graph. Does cosine start at the max, min, or middle? Max or min, in this case, will be the maximum or minimum. Very good. Nice work. So what's actually happening is we're starting at 0, and the cosine of 0, everybody remembers, is 1. You guys know, from a serious point, like, I totally get it. Not everybody remembers it. But when I say cosine of 0, this is what's happening. We look at 0 radians, and we locate 1, 0. And you say cosine is the x value. And as much as we practiced that and done that, I don't know how to get people to remember that. Are you serious? Okay. Well, the cosine of 0 is 1. And so you get 1 times 3 is 3 plus 2 is 5. So that's why it starts up here at 5. Right. Last hour I was talking with a couple students, and they understood that it started at the max. We're like, why does it start at the max? It's like, well, we're doing it every time we're plugging in 0. And the cosine of 0 is 1, whereas the sine of 0 is 0. Because all you have to remember is that point right there. Cosine's the x value, sine's the y value. As long as you remember that, you're good to go. Make sure that you put your points up to 5 and don't go down any further than -1. Otherwise, I will take points off your test because I'm a jerk. And I'm going to walk around now and see if your graphs are more like pointy mountains or if they are more like rolling hills. I see some that need some improvement and others that look just fine. It's the effort that counts. Very, very untrue statement. Next time the surgeon is operating on you, he'll say, hey, don't worry, it's just the effort that counts. Like, we don't have to get this right. Depends on the situation. Okay. All right. Well, I'm just thinking of poor Emma, because Emma has to go visit a nurse anesthetist and have a tooth removed. Is that correct? All 4 of them. And I feel bad for you, okay? But you know what? You're going to pull through. And we are going to make videos dedicated to you, Emma. Oh, my goodness. Okay. We start with the vertical shift. What's the vertical shift here? 0. Very good. What is the amplitude? 1. So what is the maximum value of the graph? 1. What's the minimum value of the graph? We good? Okay. All right. So we've got those marked out. So the vertical portion is taken care of. What's the period? 2 pi. 2 pi. Tricky, tricky, tricky. Great. Got them all marked out. Trust me, I wouldn't have you do those unless it was really worth your while. I mean, I definitely come up in situations where we're in AP Calculus and we have to produce the sine or cosine graph. We have to know the 4 spots. Definitely a case. And a third of the AP Calculus exam you're not allowed to use a calculator on. So I know what we need to prepare you guys for. So this is definitely something we want to do. Is there a horizontal shift? There is. And when you see a horizontal shift, you pause. And you actually stop to sketch a ghost graph. I know that that sounds silly. And if you want to come up with a different name, that's fine. That's my name for it. This is after working with students for many years on sketching these graphs. I find that a lot of students really struggle with the horizontal shift. And so in order to understand the horizontal shift, I encourage them to sketch a ghost graph first. I don't actually. Well, all right, here we go. So, so I sketched this graph as though there's no horizontal shift. So where does sine start? The middle. And from there it goes up. Sine, its parent graph, wants to go up. If it was negative, it would go down. And sine starts in the middle. Sine starts in the middle. And then it goes up. And it'll come back down, bottom out. This is the ghost graph. And what I do, this is what it would look like if there was no horizontal shift. I would. Okay, now can somebody tell me what is the horizontal shift? Look at the inside and set it equal to 0 and solve, and you would get, thank you, Parth, pi over 4. So I go ahead and I look at the graph and I try to determine how much is pi over 4. Is pi over 4 one tick mark? Is it more than one tick mark? Is it less than one tick mark? Yeah, it's half of a tick mark. So that means I need to take this whole graph and shift it half of a tick mark. So I could just take these spots and move it over half of a tick mark. No, like polio is awful. Okay? This is fun. Like, this is called, I had a day off of school and I decided to sketch some sine and cosine graphs because it's a good time. Well, you have to think about pi over 4 and pi over 2. How does pi over 4 compare to pi over 2? Pi over 4 is half of pi over 2. We have 2 more examples and you'll get your assignment. And I think that example C will really help you understand this completely. I can. Vertical shift for letter C. -2, very good. Amplitude for letter C. 4. So who can tell me the minimum value of this graph and the maximum value of this graph? 2 and -6. 2 is the maximum value, -6 is the minimum value. You add 4 on a -2 and you subtract 4 from -2. So I go all the way up to 2. I go down to -6. I have a vertical shift of -2. That's my axis of rotation. I have the vertical structure of the graph completed. Now, what is the period? Very good, Parth. 2. Take 2 pi and divide it by pi. I get 2. Knock off 2, -2. Is there a horizontal shift? Yes, there is. We're gonna stay away from that horizontal shift until we sketch a ghost graph. Where's this thing gonna start? The minimum. We head up, up, down, down. Horizontal shift. I take the inside pi x minus 1 and set it equal to 0. Pi x is equal to 1. Divide by pi. X is equal to 1 over pi. Goodness gracious. 1 over pi is approximately 0.31. So how much of a tick mark is 0.31? Well, 1/2 is 1 tick mark. So 0.25 would be half of a tick mark, right? So that's a little bit more than half of a tick mark. So I take all these points, I move them a little bit more than a half. Getting pretty good at this, aren't you? Y equals negative sine of 2x minus pi over 2 plus 3. You tell me where to start. You own the problem, not me. Good. Vertical shift of 3. Good. So what does that tell me? Good. Good. Got my vertical structure set up. Now what? Pi over 2, and I get pi. What's half of pi over 2? So that means my third mark will be 3 pi over 4. By the way, all you zoology kids that are at the zoo right now in the middle of winter, which is just code for, hey, we went out to Dairy Queen and watched a movie. Yeah. So your little educational bit at the zoo, I hope it's amazing. We think that in order to truly be an educational visit at the zoo, what do they need to do? Yep. Look at the poo, pick up the poo, examine the poo, and give a full report on the poo. And if you don't do that, then I'm sorry, we can't sign off on it as an academic worthwhile opportunity. That's what we decided. So take that. All right. Sketch a ghost graph. Where? Middle. And it goes down. You know, Emma, I think you're in good hands. My sister-in-law is a nurse anesthetist. She puts people to sleep all the time. Yeah, they always wake up, so. What's the horizontal shift? Ooh. Now that's interesting. Parth came up with pi. If it was pi, I would move it an entire period, wouldn't I? And therefore, the ghost graph would just be itself. But maybe it's not pi. Maybe I take 2x minus pi over 2. I set it equal to 0. I get 2x is equal to pi over 2. I divide by 2. What's half of pi over 2? So pi over 4 is the horizontal shift. So how far do I move this graph to the right? 1 tick mark. Just to prove a point, earlier in class, I took this function and I plugged it into my calculator. And I decided to graph it so that everybody could see that this is, in fact, a really accurate representation. There you have it. Good work. I'll get your packet.